Right, so we've briefly touched on mineralization, but how does it work? And you may have learned a little bit about this if you've ever taken an introductory soil science course. But I want to share with you the details of how this works, all right? Because it's not magic. It's a two-step process. In fact, it's probably more than two steps if you look at the grand scheme of what I'm going to share with you on the next few slides. So keep in mind that mineralization means the conversion of organic nitrogen to inorganic nitrogen. And the first step in this process is called aminization. Aminization is simply the breakdown of complex organic compounds into simpler or smaller organic compounds. And so when this occurs, there's no oxidation of nitrogen, meaning nitrogen is not cleaved and removed from the organic compound itself. It's not transformed yet. It's simply taking large compounds and breaking it down into smaller compounds that can eventually be degraded and release nitrogen as ammonium over time. So the first step is aminization. And this is performed by heterotrophic bacteria or fungi. So here's an example. Take a protein, which is complex. In the presence of water and fungi or bacteria, these organisms can break protein down into smaller building blocks, such as amino acids, amines, urea, and because they are aerobic, they respire CO2 and give off energy, just like humans. So, amino acids. Here's an amino acid, and look what's in here. NH2, amines, not NH4, not NH3 yet, but the precursor. Here is an amine, all right? It's a functional group with an NH2 sticking off the edge. And here's urea, right? Urea is actually used as a nitrogen fertilizer. We typically don't process or manufacture this in this fashion via this diagram. And urea doesn't have NH4 or NO3 in it, okay? But this is the first step in mineralization, something you likely haven't learned before. This takes us to the second step. And the second step is ammonification. Ammonification breaks down the simple organic compounds from the previous step into inorganic compounds. And this can happen in two different fashions, all right? It depends on the initial product that's being used during degradation. So this picture here on the left is from the previous slide. And if you take an amino acid or an amine, and this occurs in the presence of microorganisms, which isn't shown on the arrow here. But you basically take a starting point with NH2 sticking out. It's converted to ammonia gas. Ammonia gas. Ammonia gas in the presence of water can be converted to ammonium. And this is the form that plants can use, right? We can follow another pathway. We can take urea from the previous slide, and urea undergoes hydrolysis, so the splitting of water in the presence of an enzyme that's ubiquitous on the face of the planet, basically. Excuse me. So water and the presence of this enzyme converts urea to ammonium carbonate, which can dissociate or break apart or react and form ammonia gas plus CO2 plus H2O, carbonic acid. Ammonia gas here can be converted in the presence of water to ammonium. And this two-step process that you saw on these two slides is actually the mineralization process.